Saturn should not be making any sound at all. Space is a vacuum. Sound cannot travel through a vacuum. And yet right now, scientists are listening to an eerie recording of Saturn humming, a real signal captured by a NASA spacecraft. And buried inside that hum is something researchers only recently realized they had been missing for years. A completely new type of radio signal, one that matches nothing else Saturn produces, and nobody can fully explain where it comes from. And that is just the beginning. This planet has a storm shaped like a perfect hexagon that should not be able to exist. It has rings that are almost certainly the wreckage of a destroyed moon. And every 30 years, without fail, its atmosphere tears itself apart in a storm so massive that the entire planet Earth could fit inside it. Stay with me, because by the end of this video, you will understand exactly why scientists keep calling Saturn one of the strangest objects in the entire solar system. Understanding how sound can exist here at all is the key to seeing why. Sound needs a medium to travel through, and space is empty, so under normal circumstances, there should be absolutely nothing to hear out there. But Saturn is not silent, because it carries an enormous magnetic field that behaves almost like a giant natural antenna. When the solar wind, a constant stream of charged particles pouring off the sun, slams into Saturn's magnetosphere, it generates powerful radio emissions near the planet's poles. These are not sound waves in the traditional sense. They are electromagnetic radio waves. But scientists can take that raw radio data and shift it down into a frequency range human ears can actually hear, which is exactly what NASA did using data collected by the Cassini spacecraft. The result is that eerie pulsing hum you may have heard associated with Saturn around Halloween, a genuine sonification of real data, not something invented for spooky season. This particular radio signal from Saturn has been recorded and studied for decades. Scientists knew its general rhythm, its typical pulse, but in 2022, a team of researchers went back through the old Cassini data archives and found something that had apparently been hiding in plain sight the entire time. Buried inside years of recordings was a completely different kind of signal, one that did not match Saturn's usual radio behavior at all. It was officially named Saturn anomalous miriametric radiation, described in a peer-reviewed paper published in Geophysical Research Letters in August of 2022. The research team, led by scientist S.Y. Wu, identified a total of 193 separate events of this signal across the entire Cassini mission archive. Saturn's normal radio emissions follow a predictable pattern tied closely to the planet's rotation and its interaction with the solar wind. This new signal does not follow that pattern at all. It carries its own distinct frequency, drifting over time in a way the regular emissions never do, and some of these events lasted 11 hours or longer. Imagine listening to Saturn's steady, familiar heartbeat for decades, and then suddenly noticing that every so often, a completely different rhythm starts playing on top of it, coming from somewhere else, for reasons nobody has nailed down yet. Researchers know it is coming from somewhere near Saturn, based on how its intensity changes with distance, but the exact mechanism producing it remains a genuinely open question in planetary science today. Here's a thought experiment worth sitting with for a second. What if space were not a vacuum at all, and sound could actually travel freely between planets? In that world, our biggest problem would not be some distant hum coming from Saturn. It would be our own sun. NASA has also released an official sonification of the sun's radio vibrations, translated the exact same way Saturn's emissions were, producing a deep, ominous hum generated by non-stop thermonuclear reactions. Physicist Craig DeForest actually ran the numbers on this. He calculated that if space could carry sound the way air does on Earth, the sun would be blasting our planet with roughly 100 decibels of continuous noise. The rough equivalent of a motorcycle running at full throttle a few feet from your head. Except, imagine one running non-stop over every single square meter of Earth's surface, forever. The only reason we are not living inside that nightmare is the enormous mercy of the vacuum of space. But strange as that radio signal is, it is not actually Saturn's biggest mystery. That title belongs to something sitting directly above one of its poles, a shape that, according to basic physics, simply should not be able to exist. Perfect geometric shapes are about the last thing you would expect on a gas giant, defined by chaotic winds and constantly churning storm clouds. And yet, sitting at Saturn's North Pole is a massive storm system shaped almost perfectly like a hexagon, spanning a diameter more than twice the width of Earth. At its center sits a swirling polar vortex, surrounded by winds racing at speeds up to 310 miles per hour, several times more powerful than the strongest hurricanes ever recorded on Earth. Planetary scientist Kevin Baines has openly described this hexagon as one of Saturn's greatest ongoing mysteries. Under the normal laws of fluid dynamics, any vortex spinning in a liquid or gas should naturally settle into a circle. But this structure has stubbornly kept its sharp six-sided edges for more than 4 decades, ever since it was first spotted by NASA's Voyager spacecraft in 1981. Detailed images from Cassini later showed its true scale against the rest of the planet, and honestly, it looks almost artificial, like a shape someone deliberately carved into a raging ocean of gas. What makes it even stranger is that the entire hexagon rotates together as one single unified structure, completely ignoring the atmospheric chaos surrounding it. Researchers have managed to recreate a version of this effect in laboratory tanks of water, carefully adjusting rotation speed to produce similar polygon-shaped patterns in the fluid, which explains the basic physical principle behind how such a shape can initially form. What it does not explain is why Saturn's version has remained stable for over 40 straight years without ever breaking down into chaos like almost everything else in that atmosphere. Nothing like this hexagon has ever been observed on any other planet in our solar system. If a detail like that has you leaning in right now, go ahead and hit that like button because the next part of this story might be even stranger. Now let's talk about the rings, because what we thought we knew about them has completely changed in recent years. And it might be the most dramatic twist in this entire story. It is hard to picture Saturn without its rings, but for most of Saturn's existence, it did not have any at all. Saturn itself is roughly 4.5 billion years old, but its iconic ring system appears to be shockingly young, possibly only around 100 to 200 million years old, meaning the rings may have formed when dinosaurs were still walking around on Earth. In 2022, planetary scientist Jack Wisdom of MIT published research proposing that Saturn's rings are not leftover dust from the planet's formation, as scientists long assumed, but the wreckage of a genuine cosmic catastrophe. According to this model, Saturn once had another large icy moon named Chrysalis, which orbited stably for billions of years until gravitational interactions with Titan gradually destabilized its orbit. Eventually, Chrysalis drifted too close to Saturn, and the planet's tidal forces tore it apart completely. Most of the moon's mass burned up as it fell into Saturn's atmosphere, but roughly 1% of its icy debris remained in orbit, spreading out into the flat, glittering disk we now recognize as Saturn's rings. Wisdom's research suggests the gravitational shockwave from Chrysalis's destruction may have been powerful enough to physically tilt Saturn's own rotational axis, which could explain why Saturn currently sits tilted at 26.73 degrees. This research is still being reviewed by other scientists, but it lines up remarkably well with both the young age of the rings and Saturn's unusual tilt, making it one of the leading explanations in the field. And what we see today may only be a fraction of what those rings originally looked like. Researcher Yao Yahi of UC Santa Cruz modeled the earliest history of the ring system and found that in their early stages, the rings were likely far more massive and dense than they are now. Over millions of years, gravitational interactions with Saturn's moons, especially Titan, stripped away as much as 70% of the ring system's original icy material, leaving behind only the comparatively sparse remnant we see today. From a distance, Saturn's rings look completely solid, almost like a smooth, compact disk circling the planet. In reality, they are made up of trillions of individual chunks of water ice, constantly colliding and drifting in near total darkness, ranging from particles as small as a drop of water up to blocks of ice comparable to an entire mountain. Despite their enormous width, the rings are almost unbelievably thin, with a maximum average thickness of only about 2 meters, narrowing in places to as little as 33 feet. We know these precise measurements largely thanks to Cassini, which spent 13 years studying Saturn up close, and during its final orbits performed an extraordinarily risky maneuver, threading itself directly through the narrow gap between Saturn's upper atmosphere and the inner edge of its rings. The main visible ring system made up of what scientists label the A, B, and C rings, stretches out for approximately 175,000 miles. But that is not the full story. Saturn has another ring, one so faint and spread out it is nearly impossible to see, made of extremely fine particles knocked off the surface of its distant moon Phoebe, extending for an almost unbelievable 7.5 million miles into space. While the main rings are famously thin, this outer Phoebe ring is enormous by comparison, with a thickness reaching nearly 20 times the diameter of the entire planet. Saturn's rings do not exist in isolation either. They share space with an enormous family of moons, more than 140 confirmed so far, several of which shape the rings themselves. Small shepherd moons like Prometheus and Pandora orbit right along the edges of certain rings, using their gravity to keep ring particles confined into sharp, well-defined bands. Titan, Saturn's largest moon, is bigger than Mercury with its own thick atmosphere and lakes of liquid methane and ethane instead of water. And Enceladus, much smaller, hides a global ocean of liquid water beneath its icy surface, actively spraying plumes of water vapor and ice through cracks near its south pole. Plumes Cassini flew directly through to sample. Both moons are considered leading candidates in the search for potentially habitable environments elsewhere in the solar system. While the ring system itself changes very slowly over long stretches of time, Saturn's atmosphere plays by a completely different set of rules, and this is genuinely one of the most fascinating patterns in the entire solar system. Roughly once every 30 years, Saturn's atmosphere generates one of the largest storms found anywhere in the solar system, on an almost precise schedule. Most of the time, Saturn actually looks remarkably smooth and calm from the outside. But in 2010, a storm began forming on such a massive scale that even amateur astronomers using backyard telescopes were able to spot it. Cassini captured this event, known as a Great White Spot, in full development. Within just 3 weeks, the storm had grown into a monstrous system, roughly 11,000 miles wide, trailing a brilliant white cloud pattern nearly 62,000 miles long, almost a third of the way around the entire planet. Its scale was so enormous that the entire planet Earth could have fit comfortably inside it. Researchers noticed that these massive storms tend to form when Saturn's northern hemisphere is tilted most directly toward the sun. Even though the upper atmosphere sits at a frigid minus 130 degrees Celsius, scientists believe solar energy still plays the central role in triggering these storms through a slow, cumulative buildup cycle. After each megastorm settles, heat gradually accumulates far beneath the visible clouds, and water vapor stays trapped in the lower atmosphere under pressure thousands of times greater than Earth's. Thermal energy quietly builds for years, even decades, while the cold upper atmosphere acts like a lid holding everything in place. Eventually, that lid gives way. Enormous volumes of warm, moisture-rich gas surge upward in a runaway process, triggering a thunderstorm system thousands of times more powerful than anything Earth ever produces, exploding outward at wind speeds reaching 310 miles per hour. Scientists still are not entirely certain why this cycle repeats with such precise 30-year timing, but the leading explanation ties it directly to Saturn's long seasonal cycle. Since one full orbit of Saturn around the Sun takes almost exactly 30 Earth years. Inside these massive white storms, things happen that are simply not possible anywhere on our own planet. Cassini's instruments recorded intense, almost continuous lightning, sometimes flashing more than 10 times per second, striking through dozens of miles of dense atmosphere down to the deep water cloud layers where these charges originate. Scientist Georg Fischer noted that a single one of these storms releases roughly the same total amount of energy Earth receives from the Sun over an entire year. If you're finding this planet as unsettling as I did while researching it, take 2 seconds and subscribe right now, because we still have not gotten to Saturn's strangest secret of all, something scientists call the planet's energy paradox. Saturn actually radiates almost twice as much heat out into space as it receives from the Sun, despite sitting nearly 1 billion miles away from our star. In a very real sense, Saturn is generating its own internal warmth. Its core has stayed extremely hot since the planet first formed, and deep inside, a bizarre process called helium rain is constantly taking place. Under the extreme pressure found in Saturn's interior, liquid helium does not fully mix with the surrounding liquid metallic hydrogen. Instead, it separates out, much like droplets of oil separating from water, forming heavy droplets that slowly sink toward the planet's core. This has been happening continuously for billions of years, and the friction generated by that constant droplet fall releases a tremendous amount of additional heat, helping explain why Saturn runs so much hotter internally than sunlight alone could ever account for. Cassini also discovered that Saturn's north pole continues glowing intensely in infrared light even during the depths of its multi-year-long polar night, a period when direct sunlight has not reached that region for years at a time. Researchers are still working to fully understand exactly how the planet's magnetic field, its auroras, and this deep internal heat all interact to keep that glow going in near total darkness. Saturn's magnetic field itself is worth pausing on, because it is genuinely unusual, even compared to Earth and Jupiter. Most planetary magnetic fields are tilted at a noticeable angle relative to the planet's rotation axis, which lets scientists measure a planet's exact rotation rate by tracking how the field wobbles as it spins. Saturn's magnetic field strangely appears almost perfectly aligned with its rotation axis, off by less than 1 degree, making it surprisingly difficult to pin down Saturn's exact internal rotation rate through that method alone, forcing researchers to work it out indirectly, using tools like that anomalous radio signal. None of these discoveries would have been possible without a serious amount of engineering. The instrument responsible for capturing Saturn's radio emissions is called the Radio and Plasma Wave Science Instrument, a set of long antenna booms mounted on Cassini, sensitive enough to detect radio waves at frequencies measured in mere kilohertz from hundreds of millions of miles away. Turning that raw data into an audible hum required compressing years of frequency shifts into a short, listenable clip, essentially speeding up and pitch shifting a signal that would otherwise be completely silent to human ears. That same technology is what lets us hear the sun's radio output as well. The James Webb Space Telescope has also turned its instruments toward Saturn in recent years, capturing detailed infrared observations of its rings and layered atmosphere. Because Saturn's methane-rich atmosphere absorbs most incoming sunlight at infrared wavelengths, the planet itself appears strikingly dark in these images, while the icy rings, which reflect sunlight extremely efficiently, glow brightly in contrast, letting scientists study cloud structures and chemical layers invisible in ordinary visible light photographs. Almost everything humanity currently knows about Saturn in this kind of detail we owe to the Cassini spacecraft. Cassini arrived at Saturn in 2004 and spent 13 years orbiting the planet, gathering data on its rings, its moons, its storms, and its magnetic field. When its fuel supply finally began running low in 2017, NASA engineers made a deliberate decision. Rather than risk losing control of the spacecraft and having it accidentally crash into Enceladus, which scientists believe may harbor conditions capable of supporting life beneath its frozen surface, they chose to send Cassini directly into Saturn's atmosphere on purpose. Among the very last images Cassini transmitted back to Earth was one striking shot, showing Enceladus rising above Saturn's horizon shortly before the spacecraft entered the planet's upper atmosphere at tremendous speed, its structure breaking apart in the intense heat until its final faint radio signal cut off completely. That is how one of the most remarkable exploration missions in human history came to an end, with Cassini becoming, quite literally, a permanent part of the very world it had spent over 13 years studying. So, where does that leave us with Saturn today? A planet radiating a mysterious radio signal that scientists only recently discovered hiding inside decades of old data, one that still does not fit neatly into any existing model. A storm system shaped like a perfect hexagon, defying basic fluid dynamics, that has held its geometric form for more than 40 years. Rings that, based on current research, are almost certainly the shattered remains of a destroyed moon, formed far more recently than almost anyone originally expected, and an atmosphere that quietly builds up energy for decades, before violently exploding into storms so massive that our entire planet could fit inside them. Nothing about Saturn needed to be exaggerated to sound remarkable, because the actual documented facts about this planet are already stranger than fiction. As instruments keep improving and researchers keep going back through old mission archives with fresh eyes, there is a very real chance Saturn still has more surprises waiting to be uncovered, hidden somewhere in data we already have. The anomalous radio signal we started this video with was not found by a brand new spacecraft or cutting-edge telescope. It was sitting quietly inside data Cassini had already collected years earlier, waiting for someone to notice a second signal hiding underneath the first one. That means the next major discovery about Saturn does not necessarily require a new multi-billion-dollar mission. It might already be sitting in an archive somewhere, simply waiting for the right person to look a second time. Before you go, I want to know which part of this actually got under your skin the most. The impossible hexagon, the ghostly radio hum nobody can explain, or the fact that our own sun would be deafening if space could carry sound. Drop it in the comments below, and if this genuinely changed how you think about Saturn, share it with someone who still thinks it is just the pretty planet with the rings. It takes 10 seconds. And it is exactly how a story like this reaches the people who need to hear it. Stay curious, because if a planet nearly 1 billion miles away can still surprise scientists working with decades-old information, there is no telling what we might understand about our solar system next.